So hi everyone, my name's Cynthia Walker. I'm the director here at the Brickstar Museum, and I'm assisted as usual by Deb Williams at the panel. So if you have any questions as Elizabeth is speaking, please feel free to type them into the chat, and either myself or Deb or Elizabeth will be able to see them, and then we can have a question and answer period at the end of Elizabeth's lecture. The museum's Your Old House and Other Preservation Stories virtual series has explored various topics in historic preservation, especially here in Kennebunk, which boasts hundreds of historic homes and structures. Historic preservation is a constant in our community. Even the museum is housed in 5 historic buildings, which we are constantly working to maintain. So the idea of this virtual series came about because of all the knowledgeable professionals that we get to work with. In fact, as I was just mentioning to Deb and Elizabeth, we are having an upgrade to our climate control system happening over the past 2 weeks and going into the summer. So if you hear hammering or yelling or somebody discussing something as I'm talking into the microphone, just rest assured that everything's fine. We're just getting our new ducts installed in the basement. So that's exciting. This virtual series is offered for free, but if you would like to donate to the museum to support programs like these, feel free to do so by going to brickstarmuseum.org/support. Please also visit our museum's website calendar while you're there. You can see programming that's coming up, including summertime events like the vintage baseball game that's coming up on July 6th, and then something called Backyards and Barns on July 26th, which tours 4 historic backyards and barns of Summer Street, as we were just talking about, with activities at each one. So tickets for both of those things are available on our website. This is the final virtual session in our preservation series for this spring. We look forward to continuing the conversation after a summer break. So if anyone in the audience, or as you're listening later on, has interests or needs that you would like covered in this series, please email us here at the museum at info@brickstarmuseum.org with your suggestions or questions that you would like answered. As we go through the presentation today, as I said, please feel free to, if you're watching on Facebook, just type in the comments, or if you're on Zoom, just into the chat, and we will get to them during a Q&A period at the end of Elizabeth's talk. So now to our speaker today, also apropos as we sit in 85-degree weather, and I'm sure everybody needs a little bit of help. Elizabeth Paliga joined Historic New England in 2021 as the Preservation Services Manager for Northern New England. She oversees 40 privately owned easement properties, working with homeowners to answer questions about routine maintenance, as well as review proposals for their larger projects. This actually includes the museum's formerly owned property, the Taylor Barry House right on Summer Street, which we were talking about before. Elizabeth also engages with cultural history of the region by researching the lives of the people that lived at these properties. She previously worked with local governments in Scotland to protect vulnerable properties from insensitive alteration. She holds a master's in architectural conservation from the University of Edinburgh and 2 bachelor's degrees, one in archaeology and another in architectural studies from Boston University. It's wonderful to have such knowledge and skill here with us today. So Elizabeth, you take it away.
Thank you very much for the introduction, and welcome everyone. I'm going to share my screen and we'll jump right in here. All right, and just checking, this is appearing as it should.
Yes, it is coming through great. Thank you, Elizabeth.
Wonderful. Thank you very much. So we are going to talk today about energy efficiency and your old home. It's a topic that comes up a lot, both with private homeowners and also with nonprofits across New England. And it's quite a timely discussion topic, both because of the weather today and also because of our seasonal changes. So many of you may know Historic New England. Perhaps you visited one of our 38 historic sites across the region, such as the Nichols Sortwell House and Castle Tucker in Wiscasset, Maine, or the Governor John Langdon House in Portsmouth, New Hampshire. Historic New England is the largest, oldest, and most comprehensive independent heritage organization in the country. As part of its mission, Historic New England saves and shares historic homes, open spaces, collections and stories from the past to today. And through our work, we also hope to inspire good preservation practices beyond our sites and across the region. Now, within the organization, I work in the preservation services team, which builds partnerships between Historic New England and preservation-minded folks outside our organization who have the shared goal of protecting historic properties throughout the region. Now, we do that by mitigating change through legal control in our preservation easement program. We share technical guidance based on our 114 years of practical preservation experience. I like to say that we have made every mistake in the preservation book, and so I've learned quite a few valuable lessons over the last century plus. We provide educating opportunities about what makes a building or a place worth preserving, and we also strategically advocate for historic resources. Now, decisions about caring for these resources are driven by our preservation philosophy, which we codified in 2008. Now, this is a set of guiding principles that includes researching and documenting resources in order to make informed decisions about their preservation and adaptive reuse. We monitor these said resources to ensure their timely maintenance and that repairs are done that are essential for their long-term preservation. We choose maintenance and repair treatments that prioritize retaining historic material, and we also ensure that those treatments acknowledge and preserve the design and the craftsmanship that created the historic resource, not just the material. We share what we know with others, such as what we're doing today, and we also learn from others by following and improving on national and international best practices. So, Historic New England's goals for our museums are a little bit different than those of the typical homeowner, right? But this philosophy provides a really solid baseline for museums and private properties alike to ensure that decisions are made with the longevity of the resource in mind. And that brings us to tonight's topic, right? How to increase the energy efficiency of our old home. So as an organization that has spent over a century now advocating for preservation of historic places, we know it's really important to show that older houses can be adapted to modern needs in ways that are affordable, effective, and also sensitive to their historic value. One key aspect of that is to increase their energy efficiency. Now, this is a really big topic, right? So we'll start today with the big picture. Why is it important and why are we focusing on old homes? Then we'll talk about some simple things that you as a homeowner or renter could do and give you tools so you can weigh the pros and cons of common retrofits based on your home and your goals. And then we'll end with a case study of how we did this work at one of our own museums and the lessons that we learned. So let's start with the big picture. If you ignore everything else that I say today, there are 3 things that I want you to understand when it comes to energy efficiency and older homes. Firstly, old homes are not the biggest problem when it comes to energy consumption. Secondly, energy efficiency is not a new concept. It's been around as long as homes have been built. And thirdly, there is no one-size-fits-all approach to energy retrofitting an old house. So we know that being efficient energy consumers is important at a global scale, right? This chart shows data from the National Energy Information Administration, and this is how the United States uses energy. You can see that the industrial sector accounts for about 33% of US energy consumption, and residential buildings account for about 21%. However, old houses are not a very large contributor to this 21%. And note, this data is from 2021. Now, the National Register of Historic Places is the nation's official list of buildings, sites, structures, objects, and districts that are worthy of preservation. And it requires a property to be at least 50 years old, with a few rare exceptions, before it is considered even potentially historically significant. So old in National Register terms means a building built before 1974. According to the US Census, 62% of the country's 140 million housing units were built after 1969. So in National Register terms, That means only about 8% of the national energy usage is by old homes. And in case you don't think 50 years is very old, only about 12% of houses across the country are 80 years old or older. So that's, to throw some statistics at you, 17.2 million really old houses that account for about 2.5% of total US energy consumption. So old houses are not the biggest problem when it comes to energy consumption, and knocking them down for new ultra-efficient construction will not solve our global energy issues or climate crisis. Also, new construction generally utilizes more energy efficient systems, and it's also built to a higher energy code, which we can talk about. But new construction requires the development, transport, and construction of a lot of new material. It also requires the disposal of old material, and new homes tend to be about 30% larger, at least since 2000. So any efficiency is hugely offset. A quick side note, if anyone's hearing thunder, I believe a thunderstorm just rolled into my area, so apologies. So with all of this being said, we are really lucky because New England has a lot of these old houses. Between 20 and 32% of housing stock in New England was built prior to World War II. So it's worth thinking about how we as a region can increase the efficiency of our old houses. And aside from any larger impacts, it could save you some money and make you more comfortable in your home. And like I said before, improving the efficiency of New England houses is not a new idea. Chopping wood, shoveling coal, this is hard work. And so people have been pursuing ways to reduce their energy consumption for as long as houses have been built. In early New England homes, they faced south to take advantage of the sun. They used brick nogging, which you can see in the right-hand photo, and eelgrass, which is in the bottom left, as insulating materials in wall cavities. And ceilings were kept low to keep the heat closer to the occupants, not because they were shorter. The shutters kept the hot sun out in the day and also the warm air in at night. In the 19th century, double hung sash windows allowed for air circulation. You would open the top and the bottom to create a convection current in the summer. And later casement windows allowed for even more airflow. Likewise, radiators, when they were introduced, were positioned beneath these windows to create convection flows in the winter. Sash locks were used to keep windows tightly closed and to seal out drafts. Heavy drapes and rugs insulate, and doors can be closed or could be closed to keep the heat where it needed to be. Porches, likewise, helped shield windows from the high summer sun and allowed people to live outside of the warm houses in the summer. Now, today, energy efficiency is a really big industry, and starting a weatherization project can be a bit overwhelming. Right? The home improvement industry would be happy to help you make your house greener. Home Depot, the Department of Energy, all kinds of places. But not all of these resources have historic preservation or even old buildings in mind. For comprehensive information on home energy savings, I suggest looking at or starting with energy.gov to start to educate yourself. Remember that making a drastic or irreversible change to one part of the system may result in unintended consequences. But also a caveat here. Old houses have cultural memory. But from an energy standpoint, an existing house also has value for its embodied energy, the sunk costs of material and labor to create the building in the first place. And keep in mind that a lot of businesses are trying to make money by selling you new products. Right? In order to be an efficient energy consumer, you want to conserve as much embodied energy as possible. Maintain your old house. It's really the ultimate recycling. And when you are thinking of buying something new to make it more efficient, keep in mind the energy that is wasted when we choose replacement over maintenance, when we throw away serviceable materials, and when we manufacture, ship, and install new products. In fact, the construction and demolition sectors account for 25% of global waste. So a term that gets used a lot when talking about energy efficiency is net zero. This term means the total amount of energy used on an annual basis is equal to the renewable energy created. So the carbon emissions produced are equal to the carbon emissions removed from the atmosphere. It's about balancing inputs and outputs. And net zero may be a really great, ambitious policy priority, but honestly, it worries me how often it gets misapplied to make homeowners think that they have to solve the entire challenge of energy use single-handedly at their property. We'll talk more later on in this lecture about deep energy retrofits that are designed to make houses achieve this net zero. But for now, remember that our energy crisis, if you will, is systematic. Building energy efficiency into our house is only a small part of the solution. Net zero energy is not a feasible goal for each and every individual building. It's too expensive and too limiting in the types of approaches that it allows you to consider to achieve that balance, which is why it's important to consider net zero as a policy to be applied at a larger scale across your entire community, for example. Multi-building systems include high and also low energy consumers, the new construction, and buildings that are well suited to retrofits, and also buildings that are more sensitive and harder to adapt. Now, this allows a community to invest in energy retrofits where the return on that investment will be the highest. This multi-building approach also lets communities balance across different uses and different ways to adapt renewable technology across urban, suburban, and also rural areas. If you apply net zero thinking building by building, you would end up with a low-rise sprawl. But if you look at net zero at a community scale, you can preserve the density and the diversity of your building stock and still balance energy use and offsets. And finally, if you look beyond the individual buildings, there are so many other opportunities to increase energy efficiency through infrastructure improvements like water supply, wastewater treatment, the electrical grid, and transportation management. So that brings me to the last point in the big picture. In an old house, a one-size-fits-all approach to energy retrofits will not work. But there are some best practices to keep in mind. Keep your interventions simple and reversible. Avoid overly complex and costly solutions. And treat very old houses gently. They are, after all, irreplaceable. Focus more invasive interventions on new additions and also new houses. But that's not to say that old houses can't be made more efficient. They absolutely can, but we need to consider the house, its age, its use, and also what systems are in place for windows, heating, ventilating, insulation. Every house requires a somewhat different approach to weatherizing. So that brings me to part 2 of our roadmap today, what you can do. Now, while you want to be thoughtful about changes to old houses, there is still much that can and honestly should be done in any house, regardless of its age and historical significance, to make it less of an energy consumer. Start by taking advantage of historical energy efficiency resources. Use those sash locks and blinds and drapes, and think about your habits and expectations. Rather than heating your whole house to 70 degrees, close a door, put on a sweater. Next, consider the simplest interventions first. So many simple things can be done by you for little money or by a specialist at a reasonable cost, using efficient light bulbs and programmable thermostats. This low-hanging fruit gives you the best return on your investment in terms of energy savings, not to mention that expensive invasive solutions will be wasted if some of these simple fixes are not completed first. That means consider air sealing, windows, insulation, and your heating and cooling systems. A great way to decide how to get the most bang for your buck is with an energy audit. This is a test of how leaky or drafty your house really is. A blower door, which you can see in the left-hand picture, uses a fan to generate positive and negative pressure to direct air in or out of the home, at which point leaks at logical entry points are tested. Some of these leaks you can feel. Some, they use a smoke puffer to see which way the wind blows. And some use an infrared camera to show where the cold air is leaking into your nice warm house. In the photo on the bottom right, it is through the panes of glass. So this graphic shows the kinds of places that you typically find air infiltration. Once you know where the sources of infiltration are in your house, you can fill them, and the fancy term for this is air sealing. It's an obvious improvement in preventing winter drafts, but it's also really good for air conditioning in the summer. Most of the money that is spent on air conditioning is actually spent on dehumidification, and in a leaky building, that's effectively wasted money. Wood windows also can be a source of drafts, but if you are among the lucky ones that still have your old windows, keep them. Unlike vinyl, they are built to be repaired, so they can last and last and last. Now, they do need maintenance, right? Glazing, painting, sometimes carpentry repairs, or just general tightenings up. But you can enhance their efficiency with weather stripping and consider adding storm windows. Lots of studies show that a maintained wood window and a snug fitting storm window is as efficient as a double glazed vinyl replacement. And there are multiple types of storm windows. Exteriors, for instance, those made by Allied, which could be custom wood or aluminum. The pros to exterior storm windows is that they provide a really good air seal and they protect the historic sash. There's also no major impact to the interior view of the window or its operability. But in terms of cons, it can obscure that historic window from the outside, and so you want to consider the impact of the aesthetics of the building. It can also be more challenging to install seasonally. Interior storm windows, such as those made by Interglass or Indo Window, also have their own pros and cons. In the pros column, they provide a bit of a better air seal than exterior storm windows, and there's no visual impact from the outside. They can virtually disappear on the inside as well. They're also a bit easier to install or remove, but they don't protect the exterior window. There's also the potential for condensation between that interior storm and the historic sash. And if you do plan on installing them seasonally, there are, of course, seasonal storage implications of wear. It also impacts the ease of access and use to that primary window. But aesthetically, both options can virtually disappear. The decision for many homeowners relates to the ease of use and whether you need to remove and store them or any screen additions during alternate seasons. Moving on to insulation, as with all of these energy efficiency upgrades to old houses, start your insulation projects with the easiest first. It's relatively easy to insulate hot water pipes, for example, and your hot water heater, and to seal and insulate the ducts and cold air returns in the basement and the attic. Next, think about unfinished spaces that you don't need to heat or cool. The attic, for example, is a great place to insulate. It can usually be done without being overly costly or invasive. But watch out for heat sources, such as chimneys, vent fan housings, and recessed lightings. Gaps around these kinds of elements should be sealed, otherwise much of the value of that insulation will be lost. Bats can be rolled into regularly spaced openings, such as between rafters. Rigid foam can be cut to fit. And if you don't want to take up the entire attic floor, or if you have uneven cavities in your floor, you can add dense packed cellulose that can be blown in. Now, insulating your basement is a little bit more complicated, typically because that's where the heating plant often is, and there's generally also bigger moisture issues or concerns in basements. But the most valuable area to insulate is at the sill or the rim joist, and also around any penetrations like utility connections or ducts. It can be a little bit difficult to add insulation to your basement ceiling and also to your basement walls. It's a bit risky without comprehensive drainage plans and moisture control. And if adding insulation to your ceiling, to your basement ceiling, when you have your heating plants down the basement, can actually prevent hot air from rising to the rest of the house and cause more of a problem than a benefit. But what about insulating the walls of the finished rooms? So when we did an energy audit of one of our oldest properties, the 17th century Pierce House in the Dorchester neighborhood of Boston, we, Historic New England, found that only 30% of our envelope heat loss was through the exterior walls. That means that 70% of the loss was from more controllable locations like air leaks, the windows, and the uninsulated attic. Ah, there's that pesky goat again, though. Whatever you may have been told or may be told, know that introducing insulation into the walls of an old house is complicated. You could have active older wiring in the walls and retrofitted with insulation. This can be a fire hazard, and there's also the potential for moisture issues. So a former colleague of mine spotted this Greek Revival house in Connecticut several years ago now. Whatever wall insulation was added to this house, it is now harboring so much moisture that the entire framing structure can be read in the mildew patterns on the outside of the walls. This is really what preservationists fear. This is probably a 1970s oil crisis insulation job run amok. And 40 plus years later, the house is well on its way to ruin and is certainly unlikely to be a healthy interior environment for its occupants. Poorly done wall insulation is also the culprit at these buildings, where the paint is sheeting off the walls that are insulated. Now, these days, blown in or dense pack wall insulation done properly doesn't have to result in these kinds of moisture problems, but managing moisture in houses where you're breathing, cooking, showering is a complicated piece of building science. It's easier to do that when you have full access to the wall cavities, but for most historic houses, that involves removing all of the clapboards and sheathing, or all of the plaster and woodwork. And at that point, you need to consider if it's worth it, both for the cultural memory of the house and also for the embodied carbon. Spray foam is another technology that is advertised widely for insulation. It is a really good insulator, and it also effectively seals gaps. It also does not absorb moisture. But before investing in it, there are a number of things to think about. It can't be blown in through small penetrations. In finished spaces, it does require the wholesale removal of interior or exterior surfaces. It may require mechanical ventilation to maintain the air quality if you seal up a significant part of your home. Think of putting a plastic bag over someone's head and then expecting them to continue to breathe. You have to poke some holes in it to allow that to happen. That's essentially what spray foaming an entire house does to the home, to an old home. Also, spray foam off gases when it's installed, and it can release some really toxic fumes if you ever have a house fire. Spray foam also hides what's beneath it. Consider the impact on the aesthetics, but also on the diagnostic issues. For example, if you foam your attic and you develop a leak in your roof, it's going to be difficult to tell where that leak is coming from. And you may not know there even is a leak until it's much further progressed than if there was no spray foam installed. Spray foam is also not easily removed. When it's in, and you're looking at a really major effort to remove it if you ever have to or want to. So these are some pretty big downsides to compare with how much these insulation strategies will really decrease your energy consumption. But the bigger point is that if you get advice from a contractor that doesn't seem right to you, get a second opinion. It's just like going to the doctor, right? You'd never go in for a major operation with misgivings about the advice you'd gotten. It's the same way with an old house. Many contractors out there are not used to dealing with old houses. They're trying to sell you, and they may only know one way of doing things, which may not be the right way for your old home. Moving on to heat pumps. Now, electrical heating and cooling technology is increasingly popular as an energy efficient choice when owners hit that cyclical point of replacing their existing systems. And there are several different types with pros and cons. Even geothermal is a type of heat pump system. Air source heat pumps take heat from the ambient outdoor air and move it inside. This cools in the summer through the reverse. They extract indoor heat and pump it to the outside. Mini split systems, like the one pictured in the left-hand photo, are a ductless approach that can be a really good option for historic homes. You need to consider, however, the location of the inside wall hung units and also any external equipment and lines. I've always understood, though, that heat pump technology works a bit better in moderate weather as a supplement to traditional heating plant, but the technology is advancing so rapidly and it's becoming much more efficient in New England's more extreme low temperatures. Solar is another relatively new technology that has been the subject of a lot of debate in preservation circles. Now, I'm not an expert on the economic pros and cons of photovoltaic or solar hot water systems, but if you decide that solar makes economic sense for you, the next step is to have a structural engineer determine if your roof can support the installation. The weight of solar panels is not insignificant and may require you to enhance the framing in your attic to support that new system. Then you'll want to ensure that your roof is in good condition. You don't want to have to remove a fully functioning solar array to replace a failing roof. And there's a lot of debate about the visual impact of solar panels on historic homes. To mitigate the non-historic appearance of solar panels, which are reversible, you can try to avoid installing them on roof slopes that face the street, but that of course depends on your orientation. You can also minimize their visibility by making sure they are low-profile panels that are installed flush against the roof surface, and that the panels are oriented in the same direction and form a uniform shape. You may also consider a ground-mounted solar array or installing panels on an outbuilding. Now, this also depends on your site and also plot orientation, but they may be an alternative way of mitigating the structural and aesthetic impacts of solar panels on your historic home. And you can see in this photo, that was what was done here. This is a property in our preservation easement program that successfully installed solar panels a number of years ago now. Now, more costly and more complex and newer energy interventions, such as wrapping a house in several layers of rigid foam insulation and installing geothermal heating plants, get a lot of attention these days. In preservation terms, these are deep energy retrofits, and they involve subjecting older and potentially historic homes to an unwarranted and honestly unjustified level of experimentation in three critical areas: the material science, the building technology, and the construction trades. Now, these highly engineered solutions require a really high level of expertise on the part of the designers and also the installers of the systems being used. They're costly in dollars and also in energy used to manufacture and install these systems. And they have a lot of failure points and may not last long enough to pay for themselves. They also often include a substantial loss of historic material and finishes. They can result in dramatic reductions in energy consumption, but these retrofits are designed with new construction in mind, just like most building codes. An old house has very likely already moved, shifted, sagged, settled, and been altered, and so it's not really easy to square that circle, if you follow my meaning. So we need more information. We need more research on the building materials side. We need a better understanding of historical methods and practices on the building technology side. And we need more training and specialized knowledge on the building trade side. Until then, the best advice for old houses is to keep energy retrofits and interventions to a more basic level that respects the core preservation principle of reversibility and proceed slowly. If we can concentrate on enhancing the energy performance in newer homes, we will develop the expertise needed to safely, successfully, effectively, and also economically implement those strategies in older and historic houses. So this begs the question, though, do the conservative conservation approaches that I've been recommending actually work? In 2010, Historic New England put these concepts to the test at the Lyman Estate in Waltham, Massachusetts. Constructed in 1793 with major changes in 1882 and 1917. This building is actively used as offices and a functions rental site. The approach Historic New England took was to focus on reversible changes that were accessible to homeowners, minimizing harm to any of the architectural fabric of the house. And we also set a target of reducing our energy consumption by 50%. So how did we do? We used the concepts that we've talked about today. We formed a baseline measurements and metrics. We focused on air leakage, insulation, HVAC and utility improvements, and also lighting. Look familiar? We've seen this slide before. This was our energy audits, which we started with to identify our areas to concentrate the weatherization efforts. We also just looked at how much oil and electricity we were using every year. Then we got to work. We started by repairing and weather stripping all 120 historic windows. We reglazed them, repainted them, performed structural repairs, and added weather stripping. We also added storm windows. We used 3 different kinds depending on their location and the use of those spaces. We used exterior aluminum windows that are set into the window reveal. They were custom colored to match the trim, and they are practically invisible. We also used exterior wooden windows with swappable screens. And we used interior compression fit plexiglass. The infrared photo on the left was taken mid-installation and shows one window with an interior storm added and one without. Then we looked at air leaking. Now, over time, the house had new penetrations for things like plumbing and also data. We sealed those with a reversible foam product that, unfortunately, at least at the time of this, was only available in Sweden, but there are slightly less reversible options in the US. It's important, especially important actually, to start air sealing in the attic before you add blown-in insulation, or it will make quite a mess below. And then when it came time to plan our insulation work, we knew that the attic and the 3rd floor levels of the Lyman Mansion are not occupied spaces. So we chose to insulate across a continual plane at the 2nd floor, thus isolating the 3rd floor in the attic from the conditioned house. We insulated by carefully taking up the floorboards and using blown-in cellulose dense pack insulation. We also changed our fuel source to natural gas. This allowed for more efficient furnaces, and we now have 4 high-efficiency furnaces and AC. These are all controlled digitally. It's important to be aware, though, that high-efficiency furnaces do require special venting because the vapor it vents is very acidic and corrosive. So at the Lyman Estate, we chose to remove and store a basement window and to install PVC periscopes through that opening. We were then able to screen these PVC intrusions with plantings, and we painted them to match the trim. The alternative at a home is to vent through your chimney, but you absolutely must line your chimney first, again, because of that corrosive gas that high-efficiency furnaces give off. Now, poured in place cement liners that are often suggested are irreversible and can damage historic bricks and cause any future repairs to be very difficult. So Historic New England recommends stainless steel flexible liners as the best alternative. So the house also needed an overhaul of its ductwork, which comes up from the basement to service the 1st floor and down from the 3rd floor to service the 2nd. And so in the process, we discovered that the modern ductwork had been really poorly installed. In some places, it wasn't even fully connected to the vents. So we were just wasting a lot of energy, blowing hot air where it didn't need to go. At this stage of the project, we also performed some predictable activities like air sealing and insulating. And you can see the insulated hot water and hot air returns in a closet here. And then finally, we converted our historic light fixtures to LED bulbs. And this was done in 2010, right? Today, there are so many more options to ensure a really good lighting result. So most importantly, though, did we hit our goals? Now, comparing our pre-project energy use to our energy consumption afterwards, this project resulted in almost a 50% reduction in energy usage. And the work was entirely consistent with our preservation philosophy, as well as our aim to do things that an average homeowner could do. A couple of other points to make here, though. The results are entirely from use reduction and do not include any renewable technology like solar to offset our consumption. Not only a significant reduction in energy usage occurred, this happened as our overall usage of the site increased after the project. But efficiency did slightly decrease over time. The novelty wore off and staff commitment to efficient practices decreased, such as bumping up thermostats slightly or not turning off lights as judiciously. So what are the big takeaways from today? Firstly, old houses can and absolutely should be energy efficient, and making them more so may save them from unnecessary demolition later. Start with good maintenance practices and look for historic solutions and simple things that you can do yourself. Start and choose low-tech, well-researched interventions and prioritize reversibility. Weigh the benefits and the risks of standard solutions carefully, and finally, don't underestimate how our behavior impacts the efficiency of our environment. I'll end my talk today with a final tip. When in doubt, seek help from others. Historic New England is always happy to share our expertise on old house care. We have a number of resources on our website, including a variety of white papers on maintenance topics. And we also offer personal consultations over the phone or email through our homeowner services, which you can access as a benefit of premium membership. So if you are scratching your head about a particularly tricky situation at your home, definitely consider these options and reach out. And with that, I will open the floor to questions.
Just gonna stop. Here we go. So as you can see, you can unmute and turn your videos on now. So if you do have any questions, please feel free to ask Elizabeth in this period of time. Thank you so much for your presentation. That was really interesting.
I have one.
Oh, yes.
Great presentation. Thank you. I'm an architect in Maine, and I've actually done a lot of work for when it was SPNEA in the past, but nothing in this realm. And I'm just curious because I know I have institutional clients, and I know that you have many of your sites involve large sites, relatively large sites. You have the luxury of that. So I'm wondering if you've done any geothermal heat pump systems recently and how those measure up to other options. And I'm curious because the emphasis has been so much on heat pumps in general lately, and the mini splits and all that. I'm wondering if there been any changes in the technology of geothermal heat pumps as well.
Yeah, certainly there have. And it's not something I'm an expert on, but Historic New England has been doing a bit more research into the geothermal possibilities. Of course, it's site related, right? But at an institutional level, we have had a number of partners, especially down in Rhode Island, who have installed geothermal heat pumps over the last decade or so with mixed results, to be honest. Often we found that they have a lot more failure points in their systems, and so they can be quite difficult to maintain. But they, like you said, the technology is changing very rapidly. So hopefully they can become more accessible on a larger scale. They might at this point be a bit easier to maintain and install at a residential level as opposed to an institutional level. But it again depends on kind of the size and scale of the pump in general. It just also, so this isn't quite geothermal specific, but Historic New England across its organization, as you know, we have 38 house museums across 5 of the 6 New England states. And a lot of those have quite a bit of land and have varying uses, from farms to museums to shoe factories in Haverhill, Massachusetts. And we have been looking at how to bring all of our sites to a carbon neutral energy usage. We just released a climate action plan for Casey Farm, which is one of our coastal farms down in Saunderson, Rhode Island, which is a working farm. And so it's something that we're looking to implement across the region, and geothermal is definitely something that we're looking at on a site-by-site basis with regards to that. So more to come.
Thank you.
Malcolm, as you're talking about this, I thought I'd just point out there's a historic building that's not part of the museum complex, but right next to us, that was built in the 18th century, certainly added on to, but they have geothermal heating and cooling in their building that they installed, I think, about 10 years ago. If you want to be put in touch with them, if that's helpful, I can get you their information.
Okay, I might do that. Thank you.
Elizabeth, you mentioned earlier in the presentation, but what was the website that is a good resource for guidelines?
Energy.gov is just a good place to kind of start looking at energy options. There's also, I will recommend Historic New England's our site for if you have specific questions. Our white papers are all from our carpentry team, preservation team, property care team, and all our hands-on approaches to reglazing your windows or looking at insulation techniques or any number of these kind of energy efficiency measures that may be more accessible to a DIY homeowner, for instance.
Elizabeth, I actually had a question for you, because watching through your presentation, I resonated with a lot of that, because that's what the museum is working with. Our youngest building, as I like to say, is from 1860. So we are always dealing with things like this, and we just did a energy audit and saw where all of our leaking airways were and everything. And I was wondering, in your experience with visiting private homes, which are trying to deal with preservation issues, what would you say is there like a single largest issue that, like a theme that people are dealing with? Is energy conservation one of those, or are they dealing with some other things?
It definitely comes up, and I have some owners who have taken that to further lengths than others with regards to sealing. And again, they've had mixed results. There is an easement house in northern Massachusetts that has done so much air sealing and so much good work for energy consumption that they're now realizing they have condensation issues specifically on their windows because they've maybe tightened it a little bit too much, right? Old houses are meant to breathe in a way that new construction isn't necessarily. And so tightening too much is, again, that plastic bag metaphor, and it can actually result in harm to wood and other materials. So it's important to balance that and to know that whatever contractors or carpenters you are working with are aware that weep holes, for instance, are necessary for storm windows to make sure that condensation is kept at bay. That old windows are not all the same size. In fact, very rarely are two of them the same dimensions in an old house, not just because of how it was built, but because of how they've shifted and sagged. And so you may actually have a slightly non-rectangular window, and putting a replacement in can be a little bit more challenging. So these kinds of idiosyncrasies of old houses is really what we see, and they're so different. The biggest thing that I think has come up really recently is groundwater issues and water issues at our coastal properties. It's becoming much more apparent for private homeowners specifically that that's going to be a cause of concern in future years, not just with what rising sea levels are doing to foundations, and as well as impacts on maintenance requirements, just seasonal or routine maintenance requirements, but also impacts with regards to price and insurability and those kinds of concerns. So it's something we're keeping an eye on at a national level as well as a regional level. It's actually quick segue, because it's a perfect topic, or not sequitur, to our Historic New England Summit, which is an annual conference that we hold in November this year in Portland, Maine, actually,
That's right.
that where we touch on some of these kind of larger preservation questions around the region that impact homeowners, institutions, museums, educators, municipalities, local historic districts, about what's the future of preservation, and really trying to bring leading voices from a large number of interdisciplinary sources together to start having really productive conversations. And this is one of them. This is one of these kind of concerns. So if you're interested in more about that, please visit our website and look at the Historic New England Summit. But yeah, it's a very tough question.
What are some of the most common mistakes you might see people when they are trying to retrofit their home?
I'm not sure about mistakes, but where I think communication or understanding gets lost is that the resources, the very public and most accessible resources out there, are not focused on old houses. And so a lot of the prevailing guidance or even building codes or energy codes don't or should not apply in the same manner to historic buildings, because they don't work the same, they don't function the same. And it's a tall order to ask every homeowner to know that, and to be well versed and educated in what their old home might need. And so I see a lot of questions about, well, okay, we're getting an energy audit done, but these things don't sound right, or this actually did more harm than good, or they wanted me to completely just spray foam my basement, and is that what I should be doing? These kinds of questions of who to trust and what guidance to follow, that is, like I said, get a second opinion if you are ever concerned. Reach out to your local historic district or us or Brickstore Museum or someone who has had experience with this, because we've been all been tackling these same questions, to get another opinion besides just the one that might seem a little off. So that's insulation is one of the very big ones with that regards to that we see. And then also windows. Never will we not talk about historic wood windows, and how beneficial they are, not just because they can be repaired, which is fantastic. They can be kept for hundreds and hundreds of years if they're just maintained, but also because their quality is so much better. The wood that was used in historic windows is much denser and much better quality than modern wood, even custom pine windows. And so they will last longer inevitably. So that's a big one. And some of the major window installers, manufacturers out there are quite ambitious with their marketing schemes. So it's something we would like to voice as often as possible, that keep your historic windows if you have them.
Thank you. Sorry, I realized I was muted. Let's see if there's any more questions from Facebook. I think that's it.
I was gonna say, if anyone has any other questions, obviously feel free to write them now, but I want to thank, as you're doing so, I want to thank Elizabeth for joining us today. This has been very educational and hopefully buoying for some folks who are struggling, us here at the museum included, through retrofitting a lot for historic homes and historic buildings. So thank you again, Elizabeth, for taking your time to advise us on all of these things. Elizabeth's email is in the chat now if you need to get in touch with her. And of course, I do want to highlight, because I thank you, Elizabeth, for reminding us all about the Historic New England Summit that's coming up, because I needed to sign up for that. I forgot to until just now. So it does look really exciting, and since it's so close here in Portland, it would be really great to have a showing there. And again, if anyone has any questions, sorry, please visit historicnewengland.org or brickstoremuseum.org. Either one will get you to the place you need to go, and we will see you next time. Thanks, everybody.
Thank you.
Thank you.